What does that mean, balancing equations?
You gotta make them like
You got to make it even.
each side of a little arrow.
Yeah, both sides of the arrow have to be even. Why? Well, isn't there a law we learned called the law of conservation of mass? What does the law of conservation of mass say? Right. Mass can't be created nor destroyed. That means if you've got a certain mass of something on the reactant side, if the total on the reactant side of the equation is 5 grams, then that means on the product side you cannot have more than 5 grams produced, right? It also means that, and it goes back to also to Dalton's law of atomic theory. Remember, Dalton's last postulate in atomic theory said, in a chemical reaction, atoms are not created nor destroyed, right? So in other words, I can't start with 2 hydrogens and end up with 5 hydrogens. Where did the extra hydrogens come from? It also says I can't start with 2 hydrogens and end up with gold. I have to end up, if I start with 2 hydrogens, I've got to end up with 2 hydrogens. So let's first look at an equation. If I told you that hydrogen and oxygen react to make water, okay? And I'll write that in a sentence form. Hydrogen and oxygen react to make water. Could you take that sentence and write it in a chemical equation form? Okay? Try it. Take like 10 seconds and you write it and let's see what you come up with. What'd you write? You wrote H2. How'd you write oxygen? O. Yields. H2O. How come you put a 2 on the H and not on the oxygen?
I put H plus O.
Okay. Hydrogen. Take the words from the equation. Hydrogen means H. More specifically, hydrogen means H2 because hydrogen is one of those 7 diatomic elements. Remember that? Remember going over the 7? Okay. So therefore, I had to write that H2. When I say oxygen, I mean oxygen. What's the formula for oxygen? O2.
2, yeah.
Oxygen is one of those 7 diatomic elements. So I had to write H2 plus O2, and then the arrow means reacts to make or yields water. This is what I should have written. Do you see why it's an H2 and an O2 and it's not H and O? Remember the 7?
Can we have a refresher on that?
Yes. Remember hydrogen? And then I go over to atomic number 7 nitrogen, right? And it makes a 7 on the periodic table. Those elements never exist as just H or just N or just O or just F or just Cl or just Br or just I. Those 7 elements, it's always H2, N2, O2, F2, Cl2, Br2, I2. So if I say bromine, I mean Br2. If I say nitrogen, I mean N2. If I say oxygen, I mean O2. Okay, so those 7 I have to remember. If I see it written, hydrogen, oxygen, those are part of my diatomics. Now, on the left side of the equation, everything to the left of the arrow, those are called reactants. Right? Everything to the right side of the arrow, those are called products. Now, in my example, we're starting really simple. I have 2 reactants and 1 product. Is it always going to be 2 things on the left and 1 on the right? No. Okay, the reactant side can have 1, 2, 3, or 4 things. The product side can have 1, 2, 3, or 4 things, sometimes even more than that. Okay, so this is just an example. You can have any number of things on the left and the right. But when I balance an equation, what that's telling me is that the number and types of atoms on the left side has to match and be equal to the number and types of atoms on the right side. So right now, on the left side of the equation, I have hydrogen and oxygen. On the right side of the equation, I have hydrogen and oxygen. So for starters, that has to match. I can't have hydrogen and oxygen on the left and hydrogen and sodium on the right. On the left side of the equation, on the reactant side, how many hydrogens are there? 2. How many oxygens are there? 2. We good? On the right side, on the product side, how many hydrogens are there? How many oxygens? 1. So the types, the H and O's are fine, but the numbers are not okay. They don't match up, and they have to match up. I can't start with 2 oxygens and end up with 1. I can't have things disappearing because the law of conservation of mass says that can't happen. So what I have to do, guys, is I have to balance this equation. And to balance an equation, we never do this. If I do that, what did I just do? I threw a 2 on the oxygen. So now that makes this number 2, and that makes it balance, right? But H2O2 is not water. H2O2 is hydrogen peroxide. So I can't change the subscripts. What I can change, though, is I can write a number, if needed, in front of the components of the equation. That number is called a coefficient. So I balance it by changing the coefficients.
2 in front of the H.
Okay? All right. If nothing is there, is it 0? No. If nothing's there, it's always understood to be 1. Right? So right now, everything has a 1 in front of it. Right now, I see that the oxygens don't balance. So if I put a 2 in front of the water, how does that change my tallies for my product side?
4 H's and 2 O's.
It changes the H to 4 and the O to 2. So I put the 2 there. I know I'm going really slow, but I want to make sure we're all on the same page. When I put the 2 here, I did that so that I could make the oxygens balance. That is why I put the 2 there, so that the oxygens would both be 2. But in doing so, I changed the H. I've got to be sure that I apply that 2 to everything that comes after it. Is that the wrong thing to do when it throws off the H's? No, it just means now I have to go and fix the H's so that those numbers balance. So what am I going to do? I'll put a 2 here, and what does that do? That only changes this number, right? To 4, and now I have a balanced equation. Nitrogen and hydrogen react to make ammonia. If you'll recall, ammonia is a common name for NH3. Write the equation and then balance it. Are y'all getting those numbers when you start for the numbers of nitrogens and hydrogens on reactant and product? Okay? Obviously it's not balanced. To make it balanced, I'm going to add coefficients. Where do I start? Don't try to balance it all in one big lump. Pick one of them. Do you want to start balancing the nitrogen or start with a hydrogen? Just pick a place to start and only start with one atom. I would do the nitrogen first. I would get that to balance. What are you going to do to balance nitrogen? I'm going to put a 2 there. When I put the 2 there, How does this 1 change?
Turn into
2, and the 3 turns into a
2,
6. So I started with nitrogens, now I've got those balanced. Now let me look at the hydrogens. What am I going to do? The 3 there changes this to
6.
a 6. Everything matches up. That's a balanced equation. Simple. What's in front of the nitrogen? 1. Do I have to write it? No. It's understood. Okay, look, y'all, sometimes, it didn't happen on either of these that we've practiced so far, but sometimes when you balance them, you will actually overshoot the number. You just miss the number that it should have been, and you keep on working up. What you end up with is something like this. You would have a 2 nitrogen, a 6 hydrogen, and a 4 ammonia. Those all reduce by the same multiple. Yes, those would all reduce by 2. So if that ever happens, what it means is you missed the actual balance and you just went a little bit further, and you would need to reduce them.
You can tell the ratio to.
Right. The 2, 6, 4, it's the same ratio as 1, 3, 2. Okay, any questions?